Dear students, in continuation to the last lecture, the third derivation is double line to ground fault. First of all, we have to make the diagram, fault diagram. This is the fault diagram. This shows that there is a three phase A, phase B, phase C, and the phase B and phase C will become shorted to the fault impedance ZF. So, and the fault current IA, the current which is out from the F, it is IA is equals to 0. So, from this diagram we can write the equation. So, what is the equation will become? The first equation is IA is equals to 0, or we can say IA1 plus IA2 plus IA0 is equals to 0. And in case of second equation, VB is equals to VC, which is equal to the ZF into IB plus IC. And we know that when we make the equation from the symmetrical component transformation, that IA plus IB plus IC, it is 1 by 3 of IA plus IB plus IC is equals to IA0. So IA is 0 here. So the value of IB plus IC we can write it is equal to 3 IA0. So this equation will become VB plus VC. VB is equals to VC is equals to 3 ZF IA0. Or we can say that it is the fault impedance ZF and the current is 3 IA0, which is outside from these these fault. So this is the second step. We can first step make the fault diagram. Second, we make the equation, or we can write the given condition. Now third step is we have to make the equation or relationship between the sequence component and the phase component. So from the equation number 11.9 we have already make the relation between the sequence component of the current. It is equal to the IA1 plus IA2 plus IA0 is equals to 0. And for the sequence component of voltage VA1, VA2, VA0, it will become 1 by 3 of 1, 1, 1, 1, 1, alpha, alpha square, alpha, and VA, VB, VC. So VB is equals to VC. So we can, if we solve this equation, VA1 equal to the VA2, it is equal to the 1 by 3 of VA plus alpha square into VB. If we solve this is a matrix, then VA1 equal to the VA2, it will become 1 by 3 of VA plus alpha square into VB. And VA0, it will become 1 by 3 of VA plus VB, or we can say VA plus 2VB. So we can subtract equation number 11.22a and 22b. Then VA0 minus VA1, it will become 1 by 3 of 2. VA and VA will become cancelled. VB will become common. So this will become 2 minus alpha square into VB. If we find the value of 2 minus alpha square, so alpha plus alpha square, 1 plus alpha square is equal to 0. So alpha plus alpha square will become 1, minus will become plus. So 2 plus 1 is equal to 3. So 3 become cancel out. So we can say that VA0 minus VA1, it will equal to the VB. And we have already derived that VB is equals to 3ZF into IA0. VB is equals to VC is equals to 3ZF IA0. We write it is 3ZF IA0. So we get two relationship between the symmetrical component of current and voltage, that IA1 plus IA2 plus IA0 is equals to 0, and VA0 minus VA1 is equals to 3ZF IA0, and VA0 and VA1 equal to the VA2. These equations suggest that the sequence component is connected. The sequence component, or we can say that VA0 is equal to VA1 plus 3ZF. This equation suggests that the positive, negative, zero sequence component are connected in the parallel, and VA1 equal to the VA2. So these are in the parallel, and between the VA2 and VA0, the impedance 3ZF is connected. So this is the this diagram satisfy the equation. First equation IA1 plus IA2, it is equal to the IA0 minus of IA0, or we can say that IA1 plus IA2 plus IA0 equal to 0. Second thing, VA1 equal to the VA2, so VA1 equal to the VA2, and VA0 equal to the VA1 plus 3ZF IA0. VA0 equal to the 3ZF IA0 plus VA1 or VA2. So this equation, this diagram satisfy all of our equation. We can make the Thevenin equivalent of this: EA Z1 VA1, Z2 VA2, Z0 VA0. So we can write, if we make the Thevenin equivalent, we can write the fault current, or we can write the equation for the fault parameters. So IA1, from this diagram, IA1 equal to the EA. Basically the impedance EMF is only in the positive sequence impedance EA, other is the impedance only Z0 plus 3ZF. This is in the series, so Z0 plus 3ZF is in series, which is parallel with to the Z2. So Z2 parallel Z0 plus 3ZF, and the combination of Z2 parallel Z0 plus 3ZF is in series with the Z1. So whole impedance will become Z1 plus Z2 parallel Z0 plus 3ZF, or if we solve it, it will become Z1 plus Z2 into Z0 plus 3ZF divided by Z2 plus Z0 plus 3ZF. So the value of IA1 will become EA upon total impedance of this circuit. So this is how we can find the value of IA1. So from the value of IA1, we can get the other parameter also. This is given the alternate method for finding the value of IA1, but we have to focus the first method. From the diagram we can get the value of IA1. So other parameter, if we get the value of IA1, then we can get the value of VA, VB, VC, and value of IB, IC, and other parameter in the same way. If we get the value of IA1, IA2, and IA0, so this is how we can find the value of IA1. So this is the double line to ground fault. So one numerical which is also important here is given here, that it will, in this diagram, in this equation, we have to show that the given condition is that x1 equal to x2 and it is greater than x0, and there are three equations, three numericals. Basically in this diagram, it shows that write the important parameter thing, we write expression for neutral grounding resistance such that LG fault current is less than the three phase fault current. And one more thing is asked in the part C, which is important. Show that if neutral is grounded solidly, then the LG fault current would be more than the three phase fault current. Basically the three phase fault current is highest one, or the value of three phase fault current is highest, but in case of the LG fault, and the fault will occur at the generator terminals, then the LG fault, the result shows that LG fault is more severe than the three phase fault current. So this question will all ask many times in the competitive exam, that if the neutral is grounded solidly, means if solidly grounded, it means ZF is equals to 0, fault impedance ZF is equals to 0, and in that case, if the fault is occurred at the generator terminal, then the LG fault is more severe than the three phase fault current. Otherwise all other things, if fault occurred at the middle of the line and any other part of the system, then the three phase fault current is more severe. But if it will occurred at the generator terminal and generator solidly grounded, the LG fault is more severe. The calculation is very easier. You can read it, this diagram, but the conclusion which is occurred here is important in important as per the competitive exam. So this is all about the unsymmetrical fault analysis. Thank you.